Good morning, good evening, everybody. My name is Ramesh. I am the Director Solution Architect for Udemy.ai. Today I am going to walk you through the emission control through AI-powered digital twin for Sinter plant. Okay. So, so the digital twin as a concept is not very new now. We have been talking since quite a bit time until now. But with respect to the digital twin in the steel industry, specifically with respect to the central plant, is something which basically a concept in itself, which takes care of the multiple aspect of the manufacturing. And this is not only applies to the central plant, but any process which basically have a certain input, it has got a process, it has got a process control, and it has got the output as well. All right. So digital twin as a whole, which we have designed and accomplished some result through some of our experimentations with the customer in the steel industry, which basically talks about the control which is part of the recommendation generated, because any process is basically runs on the control, and control is done by the operator sitting in the center plant. An operator basically the control which he uses to run the plant depends upon his experience, the SOP which he is using, and lots of other factor which is not aware, whether it's related to the process, whether it's related to raw material quality, whether it's related to the supply chain interventions and their reflections on the process and their resulting output, either it's maybe in terms of the TPD of the productions or the return fine or anything related to the SPM, which is basically definitely very I would say the threatening with respect to the environment as well as with respect to the environmental control board restriction which they have kept on any plant which uses the coal and directly basically emitting into the environment, right? So this is just doing fall into the development as a result of the immediate solving some of the immediate problem which is caused by the deviation in the raw material quality. What kind of the control one has to take on the process so that any deviation which is largely causing the uh, reductions in the output, which is the productions, or the SPM, any increase in the SPM, suspended particulate matter, which anyhow they are releasing into the environment, and it has got certain value. It depends upon the local environmental regulations authority as well as the plant. And then the third thing is the return fine, which in itself is basically redoing the same thing, right? So the return fine is two types. One is internal return fine, another one the external return fine, which is also called the blast furnace return fine, which is not adhering to the particular size of the sinter being produced, and that's getting returned and from the blast furnace, and it could be part of the some fines getting generated as a part of the transportation logistics from the central plant to the blast furnace. So everything which is causing either redoing the same thing, or uh, you're downsizing the productions or the quality basically impact is part of how best you are able to control the parameter which in turn move the entire process and their resulting input input of the raw material, quality parameter, machine parameter, process parameter, putting everything together, how best we are able to take decision, and those decisions are getting reflected from the control room to the running process throughout the three shifts of the plant. So before the central plant digital twin was called into basically action, it was purely the experience game of by the operator running the plant, or the some people who put their thought based on the uh, multiple scenario which they have gone through as a part of the SOP. But these are very, very person dependent, not a process which takes care of itself, irrespective of whether your operator is experienced, your operator is the newbie, or basically anybody who is running the central plant should be able to produce the consistent and the good quality without impacting the environment and releasing unexpected suspended particulate matter to the environment. And, and my digital twin is exactly trying to address that problem. Yeah. Moving to the next slide. Yeah, so this is NetNet is the single slider for the work which we have done for one of the pig iron producers, and it speaks about the productions enhancement which we have made for the center plant, and now it's the we are definitely going to take it through the multiple center plant across the globe, and how what are the challenges it has got and what kind of the impact it has delivered. So, as you know, that the center plant is a connected process of multiple machines together and having many, many parameters which needs to be looked into, like a BTT, BTP, machine speed, cork trimming, and then there is at the starting of the process, there is a base mix, right? and and as in any steel plant, any manufacturing process, there is a huge dependency on the data, and the data largely we have the dependency on the DCS, SCADA, historian, etc. And the kind of the solution which we have built, it's a SaaS, software as a service, and it's deployed over the cloud. So we have basically tried to bypass the problem of the heavy data crunching on the ground, putting in a larger server on the ground, as well as as well as over the period of the time, maintenance of the model, as well as the cloud, which required the patching over the period of the time, data security, etc. Everything has been taken care by the SaaS platform, and using that, we are trying to basically establish a connectivity through the MTQQ protocol with the existing ITOT layer of the plant. And then we fetch the data. And through that, we are trying to crunch through the multiple model, which are basically developed specifically for the plant, specifically for the center plant. And this model switches gear as per the regime shifts, as per the raw material quality shifts, as per the target shifts. Okay, and there is a huge number of the combinations which it plays and give the recommendation, best suitable recommendation in the current production regime for in which the plant is running. So we are trying to optimize the control lever, and there are three output which majorly we are considering as we had discussed earlier. One is the quality parameter, which is your return fine. Second one is the production. Third one is your basically suspended particulate matter, which is nothing but the emissions. Yeah, and that pretty much we have achieved in terms of the production losses, in terms of reducing the SPM, as well as how much impact it can generate within the first 3 months, and going forward as the model and the entire platform for that matter looks into the system and learns each and every behavior of the system. Although we have we have taken quite a bit of the historical data to make the model learn, but model still has to go through as many scenario as possible to make it matured, give you the best possible or the best out of the current context in order to run your plant and the operations smoothly, because these are the very old businesses and plant have been running since years, right? And with 1.5 2 years definitely gives a very good I mean the grip over running the plant from the control room. But as far as talking about the multiple seasons, multiple regimes, changing the raw material quality over the period of the time, because sometimes domestic raw material are available in plenty, sometimes it may not be. Sometimes they have to basically import the material, right? And then accordingly, the blend has to be put so that the raw material quality is not compromised. But for every raw material quality, your thickness of the bed, your basically the way you are running your furnaces, and your BTT, BTP, and the kind of the control you need to basically keep in order to have the optimum level of the quality and the return find, like your coke trimming and your machine speed. Everything has to be in sync with if there is any change in the upstream of the raw material quality. As I said, that it depends upon the availability. Nothing is consistent over the period of the time, especially in case of the process industry, because they have happy dependency on the incoming raw material. So, so this was in context to the work which we have done for one of the big iron producers plant, which they're operating couple. I think the more than one central plant, and this is the overall connected solutions over the SaaS which we try to put it. It's a high level, basically the flow of the task. Did not a architecture detail architecture. So we are taking input as in base mix, chemistry, volume data, process data, machine data, and mapping the data as a part of the as per the process, because this data basically input comes in a certain instance of the time, and that input after a particular lead time, which is equivalent to the processing time, which is the output, where you are basically dropping the sinter onto the cooler, right? So you have the input of 30 to 40 minutes back, you have the output 30 minutes later. So that has to be put on a single time stamp, so that my machine can learn for a particular output what is the corresponding input, and accordingly if we are trying to predict and generate the recommendations, it can basically give you the good syncage in between what will be happening 30 to 40 minutes down the line with respect to any changes which you are making in the output. So for that to happen, I need to have the mapping of the data, input at certain instance of the time and output at certain other instances of the time together. And then we are doing a standard input preparation and the processing, and we are predicting the process output KPI. Like I have said, that you can have the KPI in terms of the machine speed, coke trimming, BTT, BTP, furnace temperature. If we have the basically the control over the input fuel on the furnace, then the moisture content is normally we are trying to keep it between 8 to 10%. But in the rainy season, sometimes we need to basically keep well below the the extra moisture to be added, because because the incoming material itself is moisture content is quite high, right? Then based on that, the recommendation engine give you the control parameter one, two, three. You can pick, as many as you think you can control or you have the control from your control room. It could be more than two, three, or five, but we recommend don't try to basically optimize many controls, because that will intervene with respect to the comfort level of the operator. So to start with, we try to keep it between 3 to 5, that we normally recommend to go for the control, recommended control, and accordingly, operator has to take actions. And once the operator takes the actions, that basically also has to be part of the compliance, and that compliance has to be matched against the number of the actions he has taken, as well as number of as well as the what is the optimization has been done with respect to the output, with respect to the incoming material. And sometimes there are instances where operator is not very comfortable because of the margin is not very high with respect to what he feels to be done and the recommendation which I'm generating. So there is another provision to have a two-way control simulations. You can change the input as per your convictions, and you can try to see their result into the output, as well as you can basically put the output in target and try to see what kind of the input is required. So that simulations also sometimes when they are not very confident, and which practically does happen sometimes, then they can go for the simulation part of it. Okay. Okay, so they are basically the five pillars of the industrial. These are the basically five pillars for the AI driven uh, AI driven approach, which we normally split into the control, techno-analytical approach, prediction, sustainability, and process simulations. Okay. So control, which I have already talked about, whatever, I mean, as many you want, you can control, we can give the recommendation upon. The techno-analytical approach is basically the distinguish multi-system and manual experience-based operating control to cognitive. As I said, I mean, whether you have a lesser experience or the more experienced operator, doesn't matter. If there is a cognitive approach, it basically designed to give you a consistent output with respect to the kind of the action which you take. And then there is a predictions and prescriptions. So prediction basically tells you for all the parameter, whether it's a KPI or non-KPI, I mean, what should be, I mean, the 30 minutes, 40 minutes down the time, by the time it basically impact directly or indirectly your output, what's going to happen. And the prescription is nothing but the control which we are trying to give you, based on which you are optimizing your output based on changing the control parameter. And then sustainability is a big aspect of it, and this is something which is now almost everybody is trying to attempt with a 10 years, 20 years down the line as a target, like how they can have a sustainable operations which has got the capability of the zero emissions. Although going to the zero emissions is reflection of the many parameter, but one which I think is something is really doable and we should do on the priority is the AI enabled process control. Okay. Any interventions through the, I mean, the hardware putting in the place, you are putting in place the entirely different technology which can reduce the emissions, that can definitely be done and it can impact, but that is subjected to the lot of capital expenditure. But what you can do with the existing operations is to have a AI enabled decision making, because data is almost every industry is generating, and they have the storage if they're part of the any of the digital transformations. My assumption is they have a very good data generation system and very good data repository system. And once you have it, then why not to go through a AI-enabled decision-making system, which not only take care of the quality, output, and the sustainability part of it, which anyway people are thriving to attempt at, and the target is many years ahead of now. So if you start attempting now, maybe your whatever you generate as a part of the operational dynamics can very well be taken care of, apart from the other parameter impacting the sustainability aspect, that is the emissions control. So we are trying to. I'm talking about more here on the emission side of it. I already talked about the production and quality part of it. So emissions basically we try to split into threefold: measure, trace, and reduce. We are trying to measure all the machine process input quality related parameter. Try to trace. Tracing means if there is a deviation in the output which is leading to the emissions, which part of the machine, which part of the process, which quality parameter is actually inducing that. And then based on the recommendation generated, we are trying to reduce. So they are the fundamentally three step process which we try to adopt in order to have the emissions controlled of any process across the industry. So as I talked earlier, we have a SaaS-based product. We have the entire setup of the product running over the cloud. So as far as the data is concerned, we are not only relying on the machine data, process sensor-based data, we are also taking the data from the remote sensing, satellite data, because if anything is emitting and getting exposed to the atmosphere, satellite has got the capability to track it, and we have got the inbuilt models and the provisions to track and then draw the inferences based on the delta of the enhancement of the emissions released to the environment for a particular coordinate where the industry is currently situated. Okay, then we have the land sensor, then we have the carbon audit data. There are a couple of industry who are into the carbon audit, and because there are number of the companies based on their geography, they have got very stringent uh, the carbon emissions policies. So if they have carbon audit data, that is also quite useful to us. Land sensor data that anyway, I'm assuming that any integrated steel plant or even not in non-integrated steel plant having a central plant should have it. And remote sensing data is at the top of it, validating whatever you are doing it on the ground with respect to how much you have released to the environment, where is the delta, and whether the delta is in accordance with your sensors, with your carbon audit or not. So it's like a threefold validations. One is what is coming from the sensor, another one is coming from your carbon audit data, third one we are doing from the satellite, and then putting everything together we try to drill it down from the process to the equipment to the raw material and give you the recommendations to the source how you can optimize, take corrective actions so that the final output in whatever you have in terms of emissions and the emissions can be reduced. And then once you have the reduction of the take care of the emissions, other parameters is anyway taken care of by my process control digital twin. Okay. So these are the basically second part of it. So like first part I talk about measured, and second part is like tracing. So the tracing, if we have the multiple process model, because one large process is not the reflection of the only the equipment. It can be split into the smaller process itself. So every process, a large process Y has got the smaller process X's, and these X's are contributing to those vibes. So manufacturing process model is also when a split or a big process into small process also contributes in tracking to the sources. Then we have the conventional data storage system like historian SCADA MES system, ERP system. ERP system is a transactional system because they have all the information related to the amount of the coal which you have procured, amount of the other energy sources like the natural gas, oil, etc., which you're procuring, and how much of the consumptions you are making in order to have a particular ABP target which you are trying to produce, and what is the you have with respect to the emissions target, and whether this amount which are normally are the expenditure on the raw material, can be optimized with the optimizations of the process as well or not. And then asset or sensor level data. This is pretty much at the ground level PLC devices, which are anyway, the root level data generations uh, units, which basically keep sending the pockets of the data and getting it stored in the historian and other interfaces. Yeah. And then the last one is the reducing. Reducing is nothing but the corrective actions which we take based on all the three parameter operational data stream, which I talked in the previous slide, and the kind of the recommendation we generate. And we are not only generating a recommendation, our platform allows you for the collaboration as well, because last time when you work most efficiently, everything is in control. TPD was optimum, maximum, and the return fine quality aspect was also taken care of. I mean, if you wanted to collaborate with the other team with respect to the who were part of the either maintenance, who were part of other process, who were part of other taking the corrective actions, the platform allows you to collaborate. And it also allows you to basically look into the decision taken for the based regime in which you have run the productions. So that provision is also as a part of the decision making system which we have been built as a part of our SaaS platform. Okay. Having said that, it also comes up with some challenges because it's easier said than done. Like doing something in manufacturing and especially talking about the continuous operations, a streaming of the data, operational data stream, it there are some couple of challenges. So I try to basically put some issues, the regular issues, and what kind of solutions we have put in place as of now. And definitely it will improve as we go forward, like the frequency of the coverage, right? So the frequency of the data, we can't have it on a very large time span. So we are using the satellite data in hierarchical manner to address those coverage, and the quality of the data coverage under the different weather conditions. So so we have the weather data with the LEO satellite for the data imputations which are using in order to basically bridge the delta which are impacting the factors as a part of the your impact of the weather on the incoming raw material, because not many industry are having the covered facility for their RMBB or the raw material storage area, because these most of these materials are coming in wagon and they are basically offloaded and stored in open, and that are subjected to the moisture capture. And if you are staying in a coastal region which is subjected to the unusual and the rains, especially during the rainy season, monsoon season, then we need to basically have some dependency on the satellite imaginary and their forecasting system in order to basically bring to you the best possible, the actionable in order to address the current scenario in which you are running the productions. Then operation data stream, the data gaps in the machine and the sensor data. So so there are instances where the machines is not having 100% ready or at 80 to 90% ready, and there are some portion of it is left attended with respect to the data capture. So we try to take all the design-based parameter of the machine, build a physics-based model, and run the simulation using that and generate the data and get it validated from the operation before taking those inside our model and start basically crunching the data and the AI and validating the recommendation generated by the AI, right? And then there are instances where if the scenario is not very data rich, then instead of going through the convey the AI approach method, which basically give you a very accurate result, we might have to go for the unsupervised technique. Okay, instead of the data rich approaches. So that also sometimes we do in interest of the time and interest of the time required to put the sensor in the place, then wait another couple of months to get the history of the data generated. Okay, and this is the overall layout of how we are basically trying to attack the emission reductions through the connected supply chain. Because the whatever, as I said, that you have the raw material, you have the process, you have the machine, you have the process, and then you have the output. But your direct or indirect emissions or the your energy consumption and making the energy efficient process control is not the reflection of your only process or the set of the equipment which you have in the place. This is the resultant factor of the entire supply chain inside the manufacturing facility. And in the integrated steel plant, it's very, very huge, right? So we also take care of the integrated system approach. We take care about the intra-supply chain and inter-supply chain uh, uh, data, their impact, and the each other process, and the entire manufacturing unit as a whole, how much, which process, and what kind of the control needs to be taken so the overall emissions can be optimized. This is the generic solutions to become relevant for the decarbonizing for the similar sector. So whatever we are doing for the currently for the steel industry, this can be pretty much replicated across the other process industry like oil and gas. You have the upstream, midstream, downstream, and then there is a cement industry. There are chemical industry. There are pharmaceutical industry. All are I mean the related to the process industry, part of the process industry. And we are saying that whether it's a raw material, whether it's a mining, whether it's any process industry, the kind of the framework we have put in the place, it can definitely going to help any of those. But the current solution and then the industry expertise which we have, that that's at robust solutions for any steel plant across the globe and any process. So, so in the summary, we believe and we firmly believe in this that efficiency is inversely proportional to the emissions, and B, with the help of the process control digital twin, in a specific central plant digital twin, try to make your process very, very efficient so that your emissions can go down significantly. And at the same time, you can have a better production with the maximum efficiency of your plant running in all the three shifts while taking care of your production quality. All right. So thank you from my side, and that's all. Looking forward to see you all. Uh, you can contact me directly through my email, through our website. You can put forward your query. We are more than happy to help you and more than happy to talk to you, understand your problem, and take it to, I mean, the wider goods of the steel industry, society, a steelmaker as a whole, and the metal and mining fraternity. Thank you very much.